What is the universe actually made of? Not the easy answer, but the real one. Look up at the night sky. Every star, every planet, everything glowing out there in the dark. Here is the strange part. That is almost nothing. That is not what the universe is made of. Everything you can see, every galaxy and every atom, is a tiny sliver of the whole. The rest is invisible. It gives off no light, and no one has ever touched a piece of it. We do not even know what it is, and yet we can measure exactly how much is out there. This is not science fiction. It is the best measured mystery in all of modern physics. So let us do something simple. Let us add up the entire universe, one piece at a time. We begin with everything familiar: the sun, the planets, the moons, and the comets. Add every star in the Milky Way, all 400 billion of them, blazing away. Then add every other galaxy, and there are around 2 trillion of those out there. Add all the glowing gas drifting between the stars, and every speck of cold dust. Add every atom in every rock, every ocean, and every living body, including your own. And all of it, the entire visible universe, comes to just 5% of the total. 5%. Everything humanity has ever seen is a thin film stretched over something enormous. So what is the other 95? To find it, we first had to watch the sky move. The very first clue came from a simple question: how do galaxies actually spin? Picture our own solar system. Mercury, close to the sun, whips around at tremendous speed. Neptune, far out in the cold and the dark, merely crawls along its orbit. That is the rule of gravity. The farther out you orbit, the slower you are meant to move. It works because nearly all the mass sits at the center, holding the outer worlds in check. In the 1970s, an astronomer named Vera Rubin tested that same rule on whole galaxies. She carefully measured how fast the stars orbit at the outer edges of spiral galaxies. By every rule we knew, those distant outer stars should be crawling, just like Neptune. Instead, she found a result that, by the physics of the day, should have been impossible. The stars way out at the edge were racing, just as fast as the ones near the middle. The galaxies were spinning far too fast to ever hold themselves together. With only their visible matter, they should have flung themselves apart billions of years ago, hurling their outer stars off into empty space, like mud flying off a spinning wheel. But they had not. Something invisible was quietly holding every one of them together. Something with real mass and real gravity that gave off no light whatsoever. Astronomers gave this invisible something a name. They simply called it dark matter. And the deeper they looked into the sky, the more of it they kept finding. The next clue came from light itself, bending where it should have traveled perfectly straight. Einstein had shown that mass warps space and bends the path of any light passing nearby. So a huge concentration of mass acts like a giant lens floating in the sky. Light from a far galaxy passes a massive cluster, and its straight path curves around it. We see that distant galaxy smeared into glowing arcs, or split into several separate copies. By measuring exactly how much the light bends, we can weigh the cluster that caused it. And once again, the answer came back wrong, in exactly the same direction as before. There was far more mass bending, that light than every visible star could possibly explain. About 5 times more, in fact. The same invisible mass revealed a completely different way. Then came the most convincing piece of all, in a place called the Bullet Cluster. It is the wreckage of 2 galaxy clusters that smashed straight through one another. The hot gas, the normal matter, collided, slowed down, and piled up glowing in the middle. But the gravity, mapped carefully by lensing, had sailed straight on past the wreck. The mass and the visible matter had come completely apart, separated across open space. The dark matter had passed straight through the enormous collision without slowing at all. It barely interacts with anything, even with itself. It simply drifts on through. So dark matter is not just ordinary stuff, hiding quietly somewhere far away in the dark. It gives off no light. It absorbs no light. It does not reflect a single ray. Right now, at this very moment, it is passing straight through you and through the Earth. Billions of these particles stream through your body every second, and you feel absolutely nothing. So what is it truly made of? This is exactly where scientific honesty matters most. We do not know. The leading suspects are called WIMPs, short for weakly interacting massive particles. Ghostly particles that ignore almost everything, touching normal matter only through gravity itself. Physicists have buried sensitive detectors deep underground, waiting for one to nudge a single atom. So far, after decades of patient searching, not one has ever been caught. But we can clearly see what dark matter built, written in light across the whole sky. After the Big Bang, dark matter clumped together first, long before any stars switched on. Its gravity pulled the ordinary gas inward, and that gathered gas lit up as galaxies. So the galaxies did not scatter randomly. They grew along vast, invisible threads. Threads and sheets and knots of dark matter, stretching right across the entire universe. We call it the cosmic web, and every bright galaxy sits upon its hidden strands. The visible universe is like frost, tracing the shape of a window we cannot otherwise see. Add it all up, and the case for dark matter rests on 4 separate pillars: spinning galaxies, bending starlight, the bullet cluster, and the vast cosmic web itself. 4 different clues from 4 different directions, all pointing at the very same invisible mass. About 27% of the universe, more than 5 times all the matter we can see. And if that were the whole story, it would already be strange enough for one universe. But in 1998, the universe delivered a shock far bigger than dark matter. For decades, astronomers had assumed the universe was doing one perfectly obvious thing. It had been expanding ever since the Big Bang, flying outward in every direction at once. And gravity, they reasoned, should be gently pulling all that expansion toward a slow halt. Like a ball thrown high into the air, slowing down, expected one day to fall back. 2 rival teams set out to measure exactly how fast that expansion was slowing down. To do it, they used exploding stars, the brilliant blasts called Type 1, a supernovae. Each of these explosions shines with almost exactly the same, predictable brightness. So how bright one looks to us reveals precisely how far away it truly is. They are cosmic mile markers, scattered billions of light years across both space and time. The teams found the distant supernovae, measured them with care, and waited for the slowdown. The slowdown simply was not there. The far supernovae were dimmer and so farther away than any slowing universe could allow. The expansion of the universe was not breaking at all. It was actually speeding up. Something was pushing space itself apart, harder and harder, across billions and billions of years. It was so unexpected that both teams spent months hunting for an error in the data. There was no error. The result held firm, and it later earned the Nobel Prize. Whatever is pushing all that space apart, we now simply call it dark energy. And it is by far the biggest single piece of the entire cosmic puzzle. It appears to be a strange property of completely empty space itself. Take a region of perfect vacuum with nothing in it, and it still seems to push. As the universe grows, there is more empty space, and so ever more of this push. Which means the expansion does not merely continue, it accelerates faster with every age. Galaxies are drifting apart, and the most distant ones are steadily picking up speed. Far in the future, the sky may empty out as galaxies race beyond all sight. Dark energy makes up around 68% of everything that exists in the cosmos. The single largest ingredient in the universe, and easily one of the least understood. So let us finally add up the whole universe, now that we have met every piece. 5% ordinary matter, 27% dark matter, 68% dark energy. The stuff of stars, planets, and people is the very smallest slice of them all, which leaves the one number that quietly haunts every cosmologist alive today. 95% of everything is something we can weigh, but simply cannot name. Think about what that truly means for everything we ever believed we knew. Every star chart, every photograph, every telescope image humanity has ever captured. All of it records only the faint 5% that happens to give off light. The other 95 holds galaxies together and drives them apart, entirely unseen. We named it before we understood it, like sailors drawing dragons on the blank edges of maps. And this is the astonishing place where all of our knowledge actually stands. We have mapped the universe precisely enough to be certain of one deeply humbling fact. Everything we have ever seen in all of human history is barely 5% of what is out there. And the other 95% we can measure exactly, yet we cannot begin to name. The dark matter that holds every single galaxy together, an invisible scaffold beneath the cosmos. And the dark energy that is tearing space itself apart, faster with every passing year. We can weigh it, we can map it, we simply do not know what it is. The universe, it turns out, is almost entirely made of a question we have not yet answered.